Okay, welcome, Roxy, Marina, Maddie, and Denise, and Nate, and Sophia, and Jack, and Liz, and Jose, and Jacqueline. Thanks for coming. Let's jump right into the quiz. Okay, so this time I just copied and pasted it onto the document. It'd be easier. And let's work this out. So suppose that you're offered a job selling life insurance to people who click on an interest tab, where those who click get paid $1 by you for clicking and having the conversation with you. 6% of those who click buy the standard version of the life insurance, and you get $10 paid for each of these. An additional 3% of those who click buy the premium version of the life insurance, and you get $20 for each of these. You get paid nothing for the rest. Okay, so the first is create a probability distribution table for the profit involved in this job. So let me create a table. And if you remember, X and P of X, always in the probability distribution table, X and P of X are the labels for the first and second rows or first and second columns, depending on how you write them. Any questions so far? Okay, so let me ask you, what are the possible values for X?
Nine, 19, and -1.
Okay, so 9 because you get paid $10 if you get that 6% chance, but you had to pay $1. So that's 9. And then you get the $20, but you had to pay $1 if you get that 3% really nice one. So that's 19 because 20 minus 1 is 19. And then you get paid nothing for the rest, but you have to pay $1, so it's -1. Any questions at all on finding X? Okay, so now we need to find the probabilities. What is the probability that X equals 9? What's the probability that X equals 9?
6%, so 0.06.
Yeah, so 6%, and 6% is 0.06. And what is the percent chance that X equals 19?
0.03.
Yeah, so notice 3%, and 3% is 0.03. All right, now we got to find out the probability of getting paid nothing. Okay, which means you get a probability that X equals -1. And do you remember the method of finding that last probability where you know the rest?
Add the two previous and subtract from 1.
Yeah, so we add 6 and 3, and we get 0.09. And if you take 1 minus 0.09, you get 0.91. Any questions? Any questions on coming up with the probability distribution table? Okay, so the next question, or the next part, I guess I'll call it, is use the expected value calculator below to find the expected value and the standard deviation. So let's do that. So in particular, let me just write this down so I remember. We have 9, 19, -1. We have 0.06, 0.03, and 0.91. Okay, so those are our X's and our P of X's. So we can go to the calculator, and I'll just pop it in here. We want to find the expected value. So that's expected value calculator. And then the X values are 9, 19, and -1. 9, 19, oops, there we go. 19, and -1. The P of X's are 0.06, 0.03, and 0.91. Any questions so far? So I hit calculate. So the expected value is 0.2, standard deviation is around 4. Okay, so expected value, right, EV is equal to 0.2. And if you want 40694, I'll just copy it. And the standard deviation, which is sigma, equals 4.0694. Any questions on the calculation? Any questions?
Is it okay if we didn't use the little O with the line symbol?
You mean the sigma? Yeah, you don't have to. What you do have to know is how to read it. So if I ask you and I type in the letter sigma instead of say the word standard deviation, you have to understand what I'm asking. Does that sound fair? Okay. For your projects, I want you to type in the letter sigma. Okay, because the projects are unlike the quiz, you can get help on and you have lots of time. So those are the kind of things you can figure out how to do. Does that make sense? Does that sound fair? But for quizzes and exams, I'm not picky about whether your typing is pretty. Okay, so part C, interpret the expected value using a complete sentence. Okay, so we're going to interpret the number, not just the sign of the number. Okay, certainly the sign is positive, but that's not all we want to say. Positive is a good thing, but more importantly, there were some important words that had to be in it. Do you remember the words that had to be in it? Hoping you'll all remember.
Many.
So let's start out with the word many. So if many, okay, and what we're looking at again is people clicking on the interest tab.
Trials.
Yeah, in this case, it's if many people click on the interest tab. It's not like we're doing a trial. We're looking at, customers here. People clicking on the interest tab. Then what's the next important word?
Likely.
Yep. So then it is likely that what's the next word? Do y'all remember?
Average.
Average. That the average profit per clicker will be, what's the next one? The last one?
Very close to.
Very close to. Okay, and it's 0.2. So I think the best way of saying this is 20 cents. Any questions on that? Oops, I forgot the decimal. 0.20, 20 cents. Any questions on the first question? Okay, so now let's do the second question. Okay, and the second question is the following. So suppose that 26% of all Americans have been vaccinated. Okay. I want to double check. Does this sound familiar? I'm not joking. Is this what you got? Do you remember hearing that? Do you remember reading something like this? Or does this like sound like you had something totally different? So let me know.
I've mentioned.
Huh?
I feel like I have heard it.
No, I mean the question that you had to do on your quiz. Is this the question you had to do?
Yeah.
Okay, good. Because I changed it about less than an hour before you took it. So I just wanted to make sure it actually worked. You know, with computers, you never know. I hit save, but sometimes it saves for me and then it doesn't save for everyone else. So this is correct. Okay. Because I did update this and I updated it because I wanted to get that like vaccination percent because it changes daily. So I wanted to make sure that we had that vaccination percent, you know, literally today. I looked it up on the new online today and it was 26%. So suppose that 26% of all Americans have been vaccinated. If you survey 15 randomly selected Americans, find the probability that first exactly 4 of them are vaccinated. Okay, so what we need to do is we need to go to the calculator. Let me go to the calculator. And which calculator do I want?
Binomial probability.
Binomial probability. So again, the big warning is this week, my guess is all of you knew that it was that one. But at the end of the quarter, there's gonna be a whole lot of calculators. So keep in mind that this is a binomial probability because you have several trials and each one is a yes, no question. And you want the probability of a certain number of yeses out of the survey. Does that make sense? Okay, it's hard to convince you to spend some time thinking about that. But I want to let you know it's really important each time we do one of these to think about that, even though, of course, it's binomial because that's all we've got. But that won't be true. You know, there's a whole lot of calculators here. That won't be true later in the class. So keep that in mind. You know, the reason why it's binomial, not just because this is the week of binomial. Okay, so it asks for the low. And again, we want exactly 4 to be vaccinated. So what's the low?
At 4.
Yeah, the low is 4 because if you're under 4, then you're not exactly 4. How about the high?
4.
Also 4 because if you're over 4, you're not exactly 4. So exactly is easy. It's just the same number twice. Okay, the number of trials, let's read it, is you survey 15 randomly selected Americans. So the number of trials is 15. And P is the probability that they're going to say yes. And the question is, are you vaccinated? And 26% are vaccinated. So the probability is 0.26. Any questions at all on getting into the calculator? And hit calculate, and you get 0.2273. So let me write down just in symbols, probability that X equals 4 equals 0.2273. Any questions on part A? Okay, let's do part B. What's the probability that more than 5 are vaccinated? Let's go back to the calculator. And more than 5, what's the low for more than 5?
5.
Okay, is 5 more than 5? So we want more than 5. Is 5 more than 5?
6.
Yeah, 5 is not more than 5. 6 is the lowest number that's more than 5. Any questions on that? Okay, what's the highest number? What's the high? Highest number more than 5 for this experiment.
15.
It's 15. Because if everybody is vaccinated, then that's the highest number you could get for the number who said yes to vaccinations, and you're asking 15 people. So everyone would be all 15. Trials and P don't change because it's the same idea. And you get 1713. So let's write that out. We can say probability that X is greater than 5 is equal to 0.171713. So let me stop and ask, are there any questions on either of these questions that we just looked at? Okay, so again, my biggest suggestion is practice. You'll get used to words like more than, exactly, and what to do in those cases. So this quiz is a practice because it's not that many points, whereas the exam's not. Okay, any questions at all on either of these problems? Okay, I do want to make an announcement. I think it's worth it. And that is, it's a while from now, but still, we want to make sure that we're in good shape. And that is, your exam is May 6th. Okay, that's still a few weeks, but you know, days creep up fast. And something that I very, very, very strongly recommend is the following. And that is this practice with Proctorio. Okay, the practice with Proctorio is a remotely proctored quiz. And what it does is you're going to be able to see if your computer has the ability to use Proctorio. And one of the things that you're required to have is a webcam. Okay, internet access, but obviously you have internet access as you wouldn't be doing this at all. So webcam is the main thing, internet access, but it also helps you practice. And so I set it up so you can practice many times if you can't get it to work, but you want to get it to work. If your computer does not work for some reason, maybe your webcam's broken or something, do you remember what you can do especially if you live in Tahoe?
Borrow a computer from the library?
Yeah, and that is free. You just have to let me know so I can let them know, so that, because they don't want to just give out computers to random people because they'll never get computers back. You know how that is, people just steal them. So that it's only for students. So you let me know, I give the library a heads up. Then you schedule an appointment to pick up the computer, and then you get to keep the computer until the end of June. So again, I want to make sure, you know, that nobody is not going to make it in this class because of a computer issue. But you do have to get to our library, both, you know, soon and then also end of June to return it. So that is necessary. So again, practice it. Don't wait till the last minute. You might as well practice today, you know, today or tomorrow, whatever. I set it due by 1. And basically, and in fact, if I remember right, hopefully that's true. Yeah. So it just has one question. This is just a practice for Proctorio. Make sure you can use it. Is it working? And you say true or false. Okay, and I can't make it where 0 points, it turns out. Probably Proctorio doesn't allow for 0 point quizzes. But I made it the lowest I could possibly be allowed to make it, which is 0.01 points, which is basically nothing. Just let you know, and you can retake it as many times you want. So if you can't get to work, you can keep trying. But don't wait forever, or you won't be able to have a computer for the test, and that'll be a disaster for you. Any questions on that?
I just have a question regarding the test.
The exam?
Yes, the exam. So I checked on grades and I just saw that it's worth 134 points, but it says on the syllabus that it's 150. So what's it actually worth?
Yeah, so here's how it works. So it's 134 points just because of the number of questions that are on it. Basically, it has something to do with that. But that's not the same thing as course points. So what the Canvas will do is it'll look at your grade. Let's say you got 120 for your grade. It takes 120, divides by 134, multiplied by 150, and that's how much it's going to give you. Does that make some sense?
Yeah.
So when it says points, the points could be a kind of misleading, and I apologize for that. It's just the way it is. What it really means is 15, I think, percent, something like that. 10, let's make sure 100, 200, 500, 800. Yeah. So that would mean that the exam one is 15% of your grade. And so it takes the percent that you get on exam one and then multiplies that by 15%, and that gets put into your course grade. If that means anything to you. So the 134 is pretty meaningless to you until you actually take it and you look at your grade. And then if you got 133 out of 134, it means you should be like so excited because you got a super high A. Does that make sense?
Yeah.
Yeah, so that's just a Canvas thing. Sorry about that, but you know, we live with it. But you can trust me that it's really worth 15% of the grade. Okay. So yeah, these are good questions. So it's important to ask these kind of things. And in fact, we're truly into Q&A time. So that was one question, but I can answer any question you might have. It could be about the homework, could be about the project. It could be about, I don't know, anything else. Any questions?
Do you show or do you give points if like we showed that we know how to do something on the quizzes and stuff?
Yeah, so that's why you don't want to just write the answer, because if you just write the answer and the answer is wrong, I can't give you points. Does that make sense?
Okay, I was just asking because for this problem I messed up just one number, so my calculations were off, but I did every step right.
But did you show your steps?
Uh, I showed the whole box plot like that. Yeah, I
Yeah.
showed it how it showed how you
Wait,
showed
the
it,
box plot. We didn't have a box plot on this one.
or the box that you put in,
The
or
table.
the table.
The table. Okay. Yeah, I just
Yeah.
want to correct you because box plot means something very special.
Yeah, it's different.
Yeah. So the table, you showed the table, so you get points for the table. And the idea here, this is more important on exams because exams where the big points are. Hopefully I've convinced you on that. So on the exam, you actually, what I would do on the exam, for example, on the one we just did, is I would just type in real fast, low equals 4, high equals 4, and then trials equals 15, and then P was 0.26. How long did that take me, by the way, just to type that?
A few seconds.
It's worth it. Because then let's say you just blew it and you accidentally, instead of type 2273, even though your computer, it gave you 2273, let's say you accidentally wrote 7273.
But you have all the steps.
Yeah, see, if you didn't have this first line, I can't give you really, sometimes I'll give you 1 point out of 10 or something, but I can't give you anything. Does that make sense?
Yeah.
But if you have this top line, then I look at this and say, hey, you got everything right. You just probably either didn't know how to use the calculator or had a typo. And instead of 1 out of 10, I'll give you 9 out of 10 or maybe 8 out of 10. Does that make sense?
Yeah.
So having that line in, especially for the exam, is really important. Okay, you don't do paragraphs, but just a quick little line to say, what is it that you did? Does that make sense?
Yeah.
And then I
Thank
give you credit. I want to give you credit, but I can only give you credit if I see that you've actually done something right. If that makes sense. Okay. even though you got something wrong also, if you got a bunch of right things and one little wrong thing and the wrong answer, I'll give you a lot of credit. But if I can't see the right stuff you did, I can't give you credit, if that makes any sense. And that's not just you, that's the whole class.
Thank you.
Okay, good question though. Other questions? Again, this is our question time. Okay, if there's no questions, let's get to chapter 5 then. So we just talked about discrete distributions on Tuesday. And now we're going to get into continuous distributions. Do you remember what a continuous distribution is? Can you remember? I know it's been 48 hours already. It's, it's a long time, but we talked about it a couple days ago. Do you remember what that was? Not seeing you all jump in. So what a continuous distribution, let me remind you. Or a continuous variable, I'll even use, a little easier to say, is a variable where the collection of all outcomes cannot be shown in a table, even with an infinite table. Okay, so for example, what we just did, this one, the life insurance one, this is definitely not a continuous distribution because here's a table. If you can write a table, then it's not continuous, it's discrete. Okay, and we're talking about quantitative variables always in these these chapters. So if you can't write in a table, then it's continuous. Okay, and let me give you some reminder examples. One might be, for example, how much time did it take exactly for you to do the first question on the quiz today? Okay, and the idea is maybe it took you, 9.3572178, seconds. Okay, I'm sorry, minutes, not seconds. So the idea is, because you can have all real numbers on the whole number line, then up to 20 at least, up from 0 to 20, then that would be continuous because you can't just list all the possibilities. Okay, because you can't draw a table, we have to think about different ways of representing probability. And the way we do it is with a graph. So let me ask you, see if you remember. Here's an example of a continuous distribution. And I have a question for you. It's an important one. What's the shape of this particular distribution? In one word. What's the shape? We did this in chapter 2, I believe it was.
I can't think of the word.
L?
Okay, bell is a simple word. Okay, so it's a decent answer. There's a better answer. We had a statistics word for it.
Normal.
Normal. So we called that, and this was a normal curve. Okay, we have a normal distribution. Okay, and they always kind of have the shape. They could be a little higher, a little lower, but they always have this kind of smooth, nice shape. All right. When you have something like this, we could talk about probabilities. So for example, with this particular one, we can have 1.8, which is sitting right here. We could have 2.75, which is over here. And we can say, what is the probability that a randomly selected value will be between 1.8 and 2.75? Okay, so I wrote it in symbols up here, P at 1.8 less than X, less than 2.75. So the definition of probability when we have a continuous distribution is that the probability of being between two values is the area under the curve between those two values and above the x-axis. So in particular, it's a shaded purple area. Any questions on this idea? All right, here's one big issue. Do you know how to find an area of something like this? If you're quiet, that means you do.
How does that? No.
Okay, so no. How about the rest? Do the rest of you all know how to do it?
No.
Okay, just want to make sure everyone's listening. Okay, so the idea is you don't. Okay, you don't know how to find the shape. Is there a mathematical way of finding the shape? Finding the area, at least to as many decimal places as you want. What's your guess?
Probably.
Yeah, the answer is yes, but it's intense. Okay, it's really intense. So even if you had like a year of calculus, that's probably not going to be enough for you. Okay, it's a lot of work. So what that means is that for this shape, you're not responsible for finding it by hand. Okay, that's my responsibility. And do you know what I mean by saying it was my responsibility?
Have a calculator for it?
Yeah, I programmed it in the computer to come up with these kind of things. Okay, so just let you know, for most of the distributions in the real world, that you're not going to be able to do it by hand. You're not going to be able to say, well, I know that area because I know the area formula for this Bell thing. You don't. Does that make sense? So that's one thing, is that we're not going to know the area for general curves. Okay, it's just not going to happen. But for the normal curve, there's going to be a calculator for you. And I do want to let you know that on a scale of 1 to 10, how important do you think the normal curve is? With 10 being most important of all curves for statistics and 1 being nonsense. Never going to use it. Any guess?
10.
It's a 10. I'm going to say it's the 10. Yeah, the normal curve is the curve. We're going to spend weeks on it. So just let you know that. Not on the mathematics of it, but on using it and why it is that we need this curve. So I want to let you know that even though we're going to move on and not talk about the normal curve again today, that does not mean we're moving on forever. Okay, we're going to be back at it on Tuesday. Okay, and in fact, next week and the week after is all about the normal curve, and that's all we do for 2 full weeks. Just let you know that. But this week, I'm moving on. Sound good? All right. Well, this curve we don't know how to find. Can you think of a curve that you would be able to find the area between any two numbers that you might have learned in 7th grade? Might have been 8th, might have been 6th, depending on when you learned it. I know for some of you that could have been a long time ago, but you still probably remember. What's the one curve that you really do know how to do and find the area of under?
Between 1.8 and 2.75, you subtract or add.
Right, but what curve? So this is the bell curve, right? Or the normal curve.
Yeah.
What shape would it have to be for you to actually be able to do it? This one we can't. It's too hard.
Yeah.
So what shape would not be hard? There's only one.
A horizontal line.
Exactly, a horizontal line. Because if it's a horizontal line, then you're just talking about a rectangle. Do you see that? If this were horizontal like that, you just find the area of this rectangle. Because we're finding area, and rectangle, I hope, is the one area you know how to find. Okay, there may be some others, but rectangle is the first one you learn because it's so easy. And who remembers the area of a rectangle formula? I see triangle. Triangle's true too, but rectangle is easier. Yeah, the area of the rectangle is base times height, BH. Okay, so that's just a note. Because of that, we have what I call the easiest example. So now let me give you the definition. And we say that we have a uniform distribution. Let me make this a little bigger. Since it's kind of the whole point of today. Okay, the main piece of today. So we have a uniform distribution from A to B is a distribution such that any two given intervals of length K that is contained in AB has the same probability of occurring, and any interval outside of AB has 0 probability. Okay, the distribution curve is a rectangle. And then we write, and this is important, we write X. Do you guys know how to read? Do you know what this symbol is? Right here. There's not some fancy math thing. It's on every keyboard. It's usually next to the 1. I found that most people don't know the symbol. It's like on every keyboard. It might be the only symbol you don't know. Anyone know it? Okay, if you're a Spanish speaker, you've seen it a lot because then you know ñ, and that's the symbol above the N, right? To make it an ñ. Okay, but you don't have to be a Spanish speaker because you see it on every keyboard. Anyone know what this is called? I don't usually get a lot of people that know. It's called a tilde. Tilde, tilde.
That's what it's called in Spanish.
Oh, really?
Yeah.
Most of the Spanish speakers I've talked to don't even know what it's called. So tilde. So maybe we got it from the Spanish language. I'm not sure. Yeah. So it's called a tilde. And so we say X tilde. And by the way you read it in statistics is X has the distribution of. Okay. And then U. What do you think U stands for? That should be a much easier question, given that it's in red. That's a hint, hint, hint.
Can you maybe rephrase the definition of uniform distribution? Because I'm trying to write it in my notes and it just does not make sense the way you phrased it.
All right, so it's the bottom line. That's what you need to know. Got it? So the distribution curve is a rectangle. Is that easier for you?
Not really, because it doesn't really provide much like context.
Yeah, we're
If
going
I were to read that in my notes, I would not remember.
Yeah, we're going to do a lot of examples, and from the examples, you'll start seeing it. The context will happen, but I need to
kind of need a more concrete definition.
Yeah, the concrete definition is here, but it's hard. It's mathematically intense, and that's why I read it fast, because most people don't like intense math. So then this is also a definition, and this is a lot easier to see. So the idea is that if we have a rectangle, then if you're inside the rectangle and you walk 1 unit, then and you look at the area from where you started to where you walked under the rectangle, then it doesn't matter where you started as long as you walk 1 unit, because it's base times height. Your base is 1, and the height is always the same with a rectangle.
I found a definition online that makes sense.
Okay, we'll have lots of examples. You need examples. That's why I'm kind of procrastinating this one away, because the examples are what's important. But what does the U stand for?
Union.
Not union. The hint is it's in red.
Uniform.
Uniform. It's the only other thing in red. Yeah, so we say that X has a uniform distribution between A and B, which means that If you're to the left of A, it's impossible. It'll never happen. Okay, the probability is 0. And if you're to the right of B, then also probability is 0. So say it's a uniform distribution from 2 to 10, then the probability of being greater than 100 is 0, because you're always between 2 and 10. Or the probability between 0 and 1 is 0, because you're always between 2 and 10. So that's what the A and the B mean, is that that's where the rectangle's base lies. So again, this is pretty theoretical. You really need to see examples, and this is where we do the examples. So let's go and take a look at an example. All right, so here's an example, and it's suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So the first thing we can write x tilde u, 10 comma 120. So what's nice about writing it this way is you can see everything in a very small little area, whereas this way is a big long sentence. So that's one main reason to write it this way. Next week, we're going to have some similar things, except instead of u, we're going to have an n. Any guess on what n might stand for next week? Hint is it's not going to be a uniform distribution, it's going to be the important one. Any thoughts on what n might stand for? Do you remember what I said? I don't see y'all jumping in. Okay, if you see an N, that would mean normal, not uniform. But today, we're going for uniform. Okay, but after this week, most of them are going to be normal. We're going to have some others also, but most will be normal. Okay, but today we're talking uniform from 10 to 20. Now I have some questions. If a randomly selected student who used a math tutor observed, find the probability that the student will spend between 30 and 70 minutes with the tutor. Okay. Any questions on the question? Any questions? Okay, so before we even get into the 30 and 70, I like to draw just a general picture. We know we have a rectangle because of that U means uniform. So that means we have a rectangle. We know the left boundary should be 10. The right boundary should be 120. Do we know the H? Do we know the height? Any thoughts? Okay, we don't know it immediately, but we can. So here's a question I have for you. What's the probability that if you randomly select a student, that student will spend between 10 and 120 minutes with the tutor? The hint is it's a very easy answer. Okay, I see 100. That's probably what you meant, but either you should write 100%, or even better, you can write 1. Okay, so there's 100% chance. There's 100% chance that a randomly selected student will spend between 10 and 120 minutes with the math tutor, because that's what it means to be uniformly distributed between 10 and 120. That means that anything to the left of 10 can't happen. Anything to the right of 120 can't happen. Any questions on that idea? So that means there's a 100% chance or a probability of 1 that you're between 10 and 120. All right, so the next thing is let's remember how probabilities work. So the probability that 10 is less than X is less than 120, that was equal to 1. Do you agree? Any questions on that? Now, from the definition, do you remember what probability is given a picture? And remember, how do you find probability if we're given a picture? And remember, we had a picture over here, and we said the probability was this shaded in area. So how do I find the probability of being between 10 and 120? Any thoughts? I don't see you all jumping in. So again, it's the area. How do we find the area of what we're looking at? You're all being very quiet. So how do we find the area of this? So between 10 and 120 is the whole area. How do we find this area? Remember, we have a rectangle.
Subtract 10 from 120.
Right. So we take 120 minus 10. That's the base. What do we multiply that by?
X or H if you want to.
H. X usually used for the horizontal axis over here somewhere. H for height. So we will use X, but don't put X up here or you're going to get really confused later on. Because horizontal is almost always called the X-axis. All right, now let's do some very basic math. What's 120 minus 10?
110.
110. 110H is equal to 1, right? I just rewrote the equal 1. All right, how do I solve for H? Very simple algebra.
Divide each side by 1.
Yeah, we divide each side by 110, and we get H is equal to 1 over 110. Any questions on that? I guess I should give you a heads up. You may be happy about this. You may not. I don't know. It all depends on your personality. Is that today is the most mathy day there is in the whole class? Is it starting to feel mathy? Lots of algebra and equations and stuff like that?
Yeah, definitely.
Yeah. So some of you are smiling. Some of you are frowning. I don't know you well enough to know whether you like this kind of stuff, but this is math class, so I can't, I don't feel bad about it because we're supposed to do this stuff. But today is definitely a mathy day. Nothing harder than beginning algebra, though. Okay. You don't have to know like the quadratic formula or anything weird like that. Just very basic algebra. But again, you got to pick up that old algebra. Okay, so that's what we got so far. Now let's do a little more. We want to find the probability that the randomly selected individual spent between 30 and 70 minutes with the tutor. So now I'm going to shade in between 30 and 70. Any questions on this idea? So let's write this out. probability that 30 is less than X is less than 70. Well, how do we find the area of what's shaded in? The hint is similar to the other area in terms of strategy. What's the big formula that you learned in 7th grade or somewhere around then? Okay.
So I work with a tutor outside of this class, and I went over some of these problems from the homework with her. And I can't really type it in, but I can show you my notes from that. Because the way she taught me was to put the total value of like that line under as a denominator, and then the numerator would be the value of the shaded in section, if that makes sense.
Okay, so here's the problem with that. That's good for one example, but we're gonna do lots of examples and they're all gonna be a little different. So you really got to understand what's going on here. And what's going on is, in fact, let me write it out, is base times height. This is all about base times height. If you memorize the way your tutor showed you, that'll be great for one example, but it's not going to work for part B and part C, part D, part E, and all the others. Does that make sense? So what you need to do is you need to draw the picture. You need to use the area as the base times height and then make it happen. Does that make sense? If you memorize the one formula, it's not going to work on other kind of problems. It'll only work on this one. So then you're going to have too much stuff to memorize or put on a note sheet or whatever, and it'll get too confusing. So instead, I want you to understand what's going on. And what's going on is we have a rectangle, and we're doing the area of the rectangle because the probability is the area of what's below that value in between the left and the right. Does that make sense? So I want you to learn it that way. Otherwise, you're going to get really lost really soon. So we have base times height. The base is 70 minus 30. What's the height? The hint is we just spent some time trying to get the height. So what's the height? Height's not 40. Yeah, height's not going to change. So what's the height? Hint is you're looking at it if you're looking at the whole page. I'll wait for you. What's the height? At least guess. But
Well, it says 1 over 110.
1 over 110. That's what we just spent time doing. That was the whole point. 1 over 110. Okay, and then just quickly, 70 minus 30 is 40 over 110. And we're done. Okay. If this were a computer exercise, then you have to stick in a calculator and get 4 decimals or something. But I'm happy enough on a quiz or a test if you leave it as 40 over 110. Any questions on that? Why 40? Right here. Do you see the 70 minus 30? Yeah, so that's just, all I did was the arithmetic. Any questions at all on this part A? Okay, let's move to part B. Okay. And part B is find the first quartile for the time that students spend with a math tutor. Who remembers what first quartile means?
25%.
Yeah, the 25th percentile. So the key again is the picture. So here's the picture that I'm drawing. And what's going on here is that the first quartile is a value of X. That's what we don't know. So that's what I'm going to call X. H we know that was 1 over 110. That's never changing. And if there's a 25% probability of being to the left of X, that means the area of this left rectangle is 0.25. Any questions on the picture? Any questions? Okay. So if you're ever given a probability, or if you're given a quartile, if you're given a percentile, that means you're given the area and you want to find X. So in this case, our area equals 0.25. And as always, we have a rectangle here. What's the formula for the area of a rectangle in general? It's always a good idea to write it down. Yeah, BH. What's B in this case? What's the base of this rectangle, this left rectangle? How do we come up with a base if it goes from 10 to X? Very simple, but you have to know how to do it. If you had to walk from here to here, how far do you have to walk? Again, you don't know X, so you're gonna have to, it's gonna be in terms of X. Um, 10 times X equals 0.25, not quite. Not quite. How do we get the base? That's all I want to know. None of this 0.25, just how do we get the base of this rectangle? What's its length in terms of X? So remember, let's go up here. When we went from 30 to 70, how did I get the base? I did 70 minus 30. Do you remember that? That was the base of this rectangle. If I go from 10 to X, how do I get the base? Yeah, so it's going to be in terms of X. I'm not looking for a number. How do I get the base if we're going from 10 to X? Yeah, it's X minus 10. Right? Because you go the high minus the low will give you how far you've gone. The starting, you go the finishing point minus the starting point will give you how far you walked. The height is the same H as it's always been. That's not going to change. And that was 1 over 110. Where are we? I think I lost the picture. There we go. Any questions on that? And let me remind you, this is equal to 0.25. I'm just going to rewrite it. We want to get X by itself. Very basic algebra, but you're going to know how to do algebra. How do we get X by itself now? What do we have to do to both sides to get rid of all this junk that isn't X? What's the first step? Any ideas? It's basic, it's beginning algebra, but you got to remember it. Yeah, multiply each side by 110. So I'm going to multiply each side by 110. And when I do that, I get X minus 10 is equal to 0.25 times 110. All right. Next step, to get x by itself, what do I have to do to both sides? So what's the algebra that I need to do to get x by itself? I have x minus 10. I don't want the minus 10. Yeah, I want to add 10 to both sides. So I get x is equal to 0.25 times 110 plus 10. Okay, and now that's arithmetic. So that's 37.5. Again, use a calculator. I use my brain calculator. You can use your whatever calculator you want to use. Okay. And that's the answer. So x is 37.5. So 37.5 is the first quartile. Any questions at all on this example? Any questions? Okay, let's do some others. All right, this time though, I want you to do it. So what I want you to do, let's see how many of us are there now. Okay, yeah, there's pretty many of you. So here's a question I have for you. A statistics instructor will be giving extra credit for students in the top 8% based on how long they spend with a math tutor. At least how long must a student spend with the math tutor to get the extra credit? Okay. And again, it's the same situation. We have a uniform. Maybe I'll even pop that in so you remember. So X is uniformly distributed between 10 and 120. So I'm going to give you a few minutes. I want you to try this. Again, there's one thing to watch me do it. The other is to try it yourself. So it's really important to try it yourself. I'm not going to help you for, if you ask questions, I'll answer the questions. But if you just watch me, that's too passive. So I want you to try doing it yourself, and then I'll do it. But don't just wait. Do your best. Try to do this. And the hint is it's pretty similar to either the part A or B that we just did. I'm not going to, I'll let you know it's one of those two, but it's not exactly the same. You're not going to get 37.5, by the way.
I have a question.
Mm-hmm.
Where did the 120 come from?
That was given in the problem?
Oh.
Yeah.
Oh, okay.
So suppose a student spend time with the math tutor is uniformly distributed between 10 and 120.
Okay, got it.
Yeah, so that was given. That's not something you're supposed to find or anything. That's just a given number. So again, I want to let you work on this, and you can ask questions, but I'm not just going to do it and then you watch me do it while you're passive. So do your best. It shouldn't take more than a few minutes if you know what you're doing. And if you don't, then it could take hours. You still won't have any idea. So it's not like a long problem, but it might be hard, might be easy, depending on how much you understood and how much you can do similar problems to what I just showed you. So we're on part C. Okay, you've had about 5 minutes. Let's take a look. So let me ask you, is part C more similar to A or is it more similar to part B?
Part B.
Yeah, definitely like part B. What I need to do is I want to draw a picture and I'm going to start from the base of picture, this guy. So I'm going to copy and paste it in. And kind of keep in mind part B, it's a little different, but it's not that much different. So now I'm going to edit it. So that hasn't changed. What's going to change, you want the top 8%. Oops, that's not what I want. There we go. So that's going to be 0.08. And what we need to do is we need to find this value here. I like to call it X because you're used to calling things X when you don't know what it is, especially on a horizontal axis. Any questions on the picture? Okay, then we're going to say, similar part B, we're going to say the probability, or we're going to say that the area is equal to what? So what's the area of this right rectangle now? The hint is it's easy. It's all written there. So what's the area of the right rectangle? I'm looking for a number. I don't see y'all jumping in, but this isn't a trick question or anything. It's all written there.
0.8.
0.08. That's probably what you meant, right? And the area of a rectangle is base times the height. Always good to write that down. The base now, again, it's the left minus the right. So 120 minus X. Uh-oh. And the height is still 1 over 110. And just to make it easier, I'm going to write equals 0.08 again. What do I do to both sides? First step, similar to part B. Same next step. So what do I do to both sides to get X by itself? First step,
Multiply by 110.
multiply by 110. Are you seeing it's really the same thing? 120 minus X is equal to 0.08 times 110. Okay. Now it gets a little different, but not too bad. How do I get rid of the 120? So how do I get rid of this 120? Yeah, not add 120, but
Subtract 120.
subtract 120. So we get negative X is equal to 0.08 times 110 minus 120. And then when you have a negative X, and you want to be positive, you just multiply by -1. So that means X is equal to 0.08. Sorry, times -1, so negative that. Multiply by -1 just changes the signs of everything, times 110 plus 120. And this one, I'll just show you in case you don't know. I can just go to Google, copy and paste it in. And it just gives it to me, 111.2. Any questions? Any questions on that?
So on the exam, would like that calculation you just did,
Mhm.
since you went to Google, what would we do on the test since it's we can't really use Google?
So let me show you. You're gonna have this kind of stuff, right?
Right.
See scientific calculator?
Yeah.
You can copy and paste. There it is, 111.2.
Okay.
Isn't that easy?
Yeah.
Yeah, so that's how you do it. So you can't use Google, but use scientific calculator. And the I didn't make this one actually. This was I put it into these calculators, but Desmos made this one, the scientific. So I've something called I framed it in. You don't have to know about the details of computer.
Wait, how'd you get to adding 120 back in?
Oh, what I did, see this negative right here in front of the X?
Yeah.
So what to get rid of the negative, I'll even kind of physically do it. I wrote -1 times negative X. So then we're going to have -1 times 0.08 times 110 minus 120. And when you multiply by -1, it changes the signs. Okay. Someone said they don't see why I subtracted 120. So the reason is this 120 is a positive 120. It's not the same as adding 120. I mean, this is adding 120, so that's why I have to subtract 120 from both sides. If you want,
why-
huh?
Why
Question?
don't, like, in the steps of the algebra stuff, why don't you, like, I don't get why you don't, when you're applying 110, why you don't show that and it just like remains as 0.08 times 110, because that's kind of confusing. So can you show how you would solve that if you actually, like, when you were multiplying 110
Okay,
by
I
both
went
sides, if you
times
showed that
110
solution?
times 110. You want to see that?
Yeah, like I want to see
Okay.
how
So what
that
is
works.
so what is 1 over 110 times 110?
No, that's not what I don't get. That is not what I don't get. What I don't get is like, oh, how do I?
Yeah, I'm not sure what you don't get. So if you're wondering why did I multiply by
Why
one,
do you leave it as 0.08 times 110 rather than just solving that? Because I feel like that would be
oh, you mean solve, you mean
easier to
calculate, you mean calculating that, right?
calculating that. Yeah.
If you want to, you can. That's your choice.
Can you show what that would look like, please? In like
Sure.
the
Okay, so 0.08 times 110 is that's easy because 8 times 11 is 88. So it's 8.8. But again, you can use a calculator for that. Is that clear?
yeah.
So now let me just rewrite just so you can see it all. 120 minus x is equal to 8.8. Is that clear? And I'll even put
Yeah.
it, just so it's not messy, let me put some spaces below that. And let me put on the next line. So then what I'm doing is I'm going minus 120 minus 120. Does that make sense? So 120 minus 120 is 0. Those cancel. That's the whole point. And you get negative x is equal to, now 8.8 minus 120 is negative 111 let's see, 0.2. That you can use arithmetic if you want. Are you okay with that?
Yeah, that makes a lot more sense.
Okay, and then multiply both sides by -1. And -1 times -x is x. And -111.2 times -1 is positive 111.2. So same thing. This is kind of showing each little tiny basic algebra step. Any questions on that idea? Okay, so very important that you can do this kind of stuff. And this, by the way, this is why I said you need to have the rectangle, because otherwise you're never going to get started. You got to be thinking base times height and working it out, because there's actually a little algebra to do. All right, I'm going to skip some of these others. Let me do this one, part F, because F is a nice important one. What is the probability that a student spends exactly 25 minutes with a math tutor? And the hint is it's really easy. Can you tell me? And I'm going to recreate the rectangle. So what's the probability that the student spends exactly 25 minutes? And the hint is it's super easy. I don't see y'all jumping in. I'm going to draw the picture and that might help. So 25. So it's not 15. So 15 over 110 would be the probability that the student spent less than 25 minutes. Because what my guess is what you did is you did, well, base times height, you looked at this rectangle, but this rectangle is all the numbers less than 25. That would be more than, if you did 120 minus 25 times 1 over 110, that'd be more than 25. Okay, it's so easy, it's tricky. Yeah, B and A are exactly 25. What's the probability of being exactly 25? How wide is this line here that I've drawn? Exactly 25 means you can't go farther left or farther right than this line. What's the area of a line segment? Not length, but area. Not 1 over 110?
0.
What'd you say?
0.
0. So the answer is 0. Do you agree that was really easy if you know what to do? So probability that x is exactly equal to 25 is just 0. And that's it. That's all you have to do. What's the probability that x is exactly 40?
0.
0. Now are you starting to agree that this is really easy? So when you have a continuous distribution, the probability of being exactly a certain number is always 0. Isn't that nice? It does put some of what you are used to thinking about, it twists your brain a bit. Because the probability being 0 does not mean it can't happen. And that feels weird, doesn't it? Because
I
25
feel like that
can.
doesn't make sense in practice. Like, sure, in theory it makes sense, but in like an actual scenario would not make that just no, that does not make sense.
Okay, so think about it. Okay, so now, okay, do the actual scenario. Okay, let's pretend you're Braulio, because that means you're looking at a tutor. And the next tutor who walks in, you're going to look at your watch. Okay, and your watch goes to more than 1 million decimal places. Got it? Do you really think that the person is going to walk out of the room at exactly 25 minutes? Up to
It
millions?
could happen. Technically, it could happen.
It could happen, but the
Also, watches
probability.
in real life do not have that many things. So, like, in a real life scenario, without that like caveat of, oh, your watch has so many little notches on it that it's impossible, but like within a real world scenario,
It could happen, but the probability is so small. What we say is a limit, it is 0. So when you have a continuous distribution, the probability of being exactly a number is always 0. Okay, and that has to do with the fact that the area, the base is just 0 because there is no width between 25 and 25. Because remember that we're talking about the base times the height. The base has 0 width. Does that make sense? If it doesn't feel right, then all I can tell you is math sometimes feels weird. But it is the way it is. Any questions on this? Okay, next comes a big formula, theorem formula. And here's the big theorem. If X is uniformly distributed between two numbers, A and B, then two things. The mean is A plus B over 2. That should be pretty obvious. Again, looking at the picture in the original problem. If I said that we have a uniform distribution between 10 and 120, and I asked you what the average amount of time, which is the mean is the average, right? If I asked you the average amount of time people spend in the math lab, with math tutor, how would you find the average? That'd be right in the middle. Do you agree? How do you find this middle number between 10 and 120? What do you do? How do you find the average? And this isn't supposed to be tricky or anything. It's not quite as easy as the probability exactly 25, but it's not tricky like that one was. Okay, how do you find the average if it's between 10 and 120? Or the mean? How do you find the average of two numbers? This is something that you should know from like probably 5th grade. You've been doing this a long time. I don't see everyone jumping in. Does that mean you don't remember, or does that mean you're just being quiet because, I don't know, something else is going on? So how do you find the average of two numbers? So how would you find the average of 10 and 120? Any thoughts? Either you say you forgot, or I'll wait forever. Or tell me the answer. So I'm watching the chat box, I'm listening. How do you find the average of two numbers? How do you find the average of 10 and 120? Because that's right here in the middle. Can you hear me? Ah, there we go. No, that was Braulio, but hoping that the rest of you are listening. How do you find the average of two numbers?
Ten plus 20 divided by 2, which would be 70.
It's 10 plus 120 over 2 is what you meant, right?
Yeah.
Yeah, 10 plus 120 over 2, which would be actually 65. Okay, but I'd rather have an almost perfect answer than just quiet. Okay, what you do is you add the two numbers and divide by 2. Okay, you learn that. You've known that forever, I hope. Okay, so in particular, we have this big formula that the mean for a uniform distribution is just the average of the two numbers, a plus b over 2. Okay, on the other hand, the standard deviation, I wouldn't even dream of you knowing why this one's true. It's the square root of b minus a quantity squared over 12. So that's the old trust me. Okay, I could prove it for you and you'd probably all be lost because it involves calculus. I'm not going there. But here's what you do need to do. You need to have this written down. You need to have this put on your note card so that if I ask it on an exam, you've got it in a note card. So I don't make you memorize formulas, but I want you to understand how to use them and when to use them. Any questions on this theorem? Okay, so now I have an example. And here's what it says. Suppose that the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces, right? You tend to, put more water in your bottle than you do drinking out of the fountain. Okay, you watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? And the big hint, if you remember, if you want to find out, if you want a measure of how unusual something is, this is very important for your projects. What you do is you find the z-score. Okay, and in fact, you can look for outliers, etc. So to find a z-score, who remembers the formula for z-score? It's a pretty simple formula. And you remember? Okay, so if you don't remember, let me show it to you. I know why. Let me hit enter a few times so I can be on the same page. There we go. So the formula is z equals x minus mu over sigma. Okay, and then just let me copy and paste so we still have it. Mu is a plus b over 2. Sigma is b minus a squared over 12, all under the square root. So we want to look at a few things. Let's look at Thorne's situation. So Thorne just drank out of the fountain. Well, we know that drinking out of the fountain is uniform between 1 and 8. So we have x tilde u 1 comma 8. Any questions on writing that out? All right, so I have a question for you. What is mu? What does it mean for Thorne? For drinking out of a fountain? Looking for a number. And might take you a moment, but not too long. So what's the mean? So mu equals, let's see if you can tell me. The hint is all the information is there for you. You just have to plug in. So what is the mean? It's not a tricky question. It's a plug-in question. No idea? Okay, well, we have a plus b over 2, right? What's a? So what is a? It's all given. It's right here. What's a? Yeah, a is 1. What's b? B is 8. And then over 2. You can pop that in a calculator if you want, and you get 4.5. Any question? Did I lose anyone there? Again, it's just plugging in the number 1 and 8 for a and b, because x is uniform between 1 and 8. A is 1, b is 8. Okay, sigma is messier, but not really any harder, just messier. So sigma is equal to the square root of the fraction b, which is 8, minus a, which is 1, squared over 12. And let me make that bigger because it always gets really little. There we go. And again, this one you got to be able to do in your calculator. So this is the square root of 7 squared over 12, square root of 49 over 12. So let's just do that. And that's about around 2. I'm going to use one decimal place is enough, and that gives me 2. Any questions so far? Okay, so now I need to find z. So z is x minus mu over sigma. What's x in this case? You got to read the question. And we're focusing on Thorn right now. And what's x for Thorn? Here's Thorn's information. What's x? And it's not a trick question. It's all there for you. So what is x? What's it say? You watch Thorn take 2.5 ounce drink out of the drink fountain. So what's x? Are y'all paying attention?
$2.5.
Yeah, 2.5. It's not a trick question because it says 2.5 was the amount that Thorn took out. It's not a mean, it's not a standard deviation, it's the value. So it's 2.5 minus, the formula says we're supposed to take x minus mu. Mu was 4.5. And then we're supposed to divide by sigma, which was about 2. And what I get, 2.5 minus 4.5 is -2. -2 over 2 is -1. You use a calculator too, but this one was pretty easy. Any questions on that? All right, what I like to do now, just to make it easier to understand, I think. Is I'm going to copy and paste and change what I need to. First, I'm going to change Thorn to Preston. Okay. And by the way, Thorn and Preston were students of mine in a stats class some years ago. So I like to use this one because they had cool names. Okay. We're not uniform between 1 and 8 anymore. Now Preston is filling the bottle. Okay. And the bottle, it says, is uniformly distributed between 4 and 16 ounces. So I'm going to take that 1 and 8, change it to a 4 and a 16. Any questions on that? Okay, now our mu is no longer be 1 plus 8 over 2. What's it now for Preston? Hopefully you paid attention. So what's mu for Preston?
Can you make it bigger?
Sure. How's that?
Good.
So what's mu for Preston? It won't be 1 plus 8 over 2 because that was more.
16 divided by 2.
Yeah, it'd be 4 plus 16 divided by 2. 4 plus 16 is 20. 20 divided by 2 is 10. Similarly, sigma won't be 8 minus 1 squared over 12 with the square root. What changes for sigma?
Eight minus one becomes 16 minus 4.
Exactly. 8 minus 1 becomes 16 minus 4. Okay, so we get the square root of 16 minus 4 squared over 12. By the way, 16 minus 4 happens to be 12. 12 squared over 12 is actually 12. So we're looking at the square root of 12. Okay, you could do the whole thing with a calculator, but I decided to do it the easy way. And that's about 3.46. Okay. What is Preston's X value? And the hint is I've highlighted the information you need.
Five.
Yeah, it's 5 because Preston filled his water bottle with 5 ounces. So that means this 2.5 becomes a 5. The 4.5 is now 10 because that's the mean. And standard deviation is 3.46. Any questions on that? So we get 5 minus 10 is negative 5 over 3.46. Let's just do that. Negative 5 over 3.46. And I get about 1.45 negative. Any questions? All right, so who's more unusual? Let's make this one big too. Who's more unusual, Thorne or Preston, based on the z-values? So who is more unusual? So look at the z-values. We got a z of negative 1 for Thorne and a z of negative 1.45 for Preston. So who's,
Preston.
Yeah, Preston is more unusual. Since Preston's z score is farther from 0. Any questions on this? Any questions? Okay, something I want to do, and we'll see how productive it gets, is I want to get into the project. Do any of you have a draft to show me? Remember, today's the day to send the draft, to give me the draft so that I can take a look at it. Have any of you created a Project One draft yet? Do y'all remember when the project's due?
Tuesday.
Tuesday before class. Okay, so this is the time. So if you don't have a draft, maybe you do have a draft and you're just being quiet because a lot of quiet people today. If you don't have a draft, do you have questions? Okay, but if you have a draft, that's even better. But if you don't have a draft, do you have any questions about your particular project? So I'm really hoping to help you out. What's the best way to get the survey to people? It depends on your survey. So because of COVID, most of you are going to be doing internet. And that could be email, it could be social media. Yeah, so the most important thing, as long as you are either doing stratified sampling or cluster sampling, you can choose any way you want to get the data, to get your data. Okay, but you have to choose either stratified or cluster. And you have to, formally, write that out, what you did, and make sure that's part of your plan. So for example, if you stratified by, let's say your population were Californians. Again, you have to decide what your population is too. Let's say your population were California adults. Then you go online, and let's say you wanted to stratify. Okay, so if you're doing stratified, is there a wrong or biased way to get survey results? So I will let you know that all ways of getting survey results have bias when you're doing a regular survey. There's always going to be bias. So the project is not about having no bias, because that would be impossible. What it's about is doing a trial run or a practice so that you can experience either stratified sampling or cluster sampling. If you're doing an online sample, you're probably going to stratify. Cluster is very hard to do online because you have to get everyone to answer, which is almost impossible online. Okay, so if you were going to stratify, say, by race, and let's say your population were California adults, you would go online and you type in, what percentage of adults are, Caucasian, what percent are Hispanic, and maybe other. Okay, make it simple, just do the 3. Then you multiply those percents by your sample size, and then you just make sure that in your total sample, you have made those quotas. So let's suppose that you looked at California and it was 40% Hispanic. Again, don't quote me because I don't know exactly the percent Hispanic. And let's suppose your sample size was 35. Then you take 40% of 35. Okay, and 40% of 35 is 14. You can stick that in a calculator, or trust me. So then make sure that you survey exactly 14 Hispanic. So if a 15th Hispanic answered your question, you don't use that person's answer. Does that make sense? And then you do the same thing for the other races, Caucasian and maybe other. Okay. And is there going to be bias? Absolutely. I don't take off points for bias. I take off points for not identifying and writing about the bias. So most of you are going to have some kind of voluntary response bias, because not everyone's going to answer your question. You're going to send a Facebook thing or whatever your social media is, and some people are going to answer, some aren't, or an email or whatever. And if not everyone answers, then there's going to be voluntary response bias. Okay, there could be other biases too, and you just got to identify them. So again, you don't lose points for having bias. You lose points for not writing about it. Do you see the difference? Okay, and if you think there's no bias and you write there's no bias, then yeah, I'm going to take off points because you're wrong. There's always bias. I have office hours Monday through Friday. And remember, in fact, why don't I pop in the syllabus? Because they're in the syllabus. So Monday, Wednesday, Friday, 10:10 to 11:10. And then Tuesday, Thursday isn't going to help you because Tuesday at 6 is already past the turn-in time. So tomorrow at 10:10, I have office hours in the morning. And I'll definitely be sitting on Zoom. Same Zoom link, always the same. Nothing changes. I also have office hours now, or not now, but in a few minutes. And just let you know, with office hours, we take turns. So if there's 4 people that come to office hours, you ask a question, I answer it, and then I have the next person, and then you just take turns. And if you have a few questions, then you go in a sequence. That's kind of how I handle it. If I have more if I have more than one person asking questions. Just a note, in terms of turning in your project, only one of you per group turns in your project. Okay, but make sure when you turn in the project, on the project itself, write down the names of the people in your group so that I can give points to everyone in the group. Any more questions? These are good questions, but I did want to spend some time about the project. Any more questions? And Braulio is going to be around a lot. Again, I got 1 office hour. Braulio, you have probably more than 1 office hour between now and Tuesday at 3:30, right? Maybe you can pop in the chat box when you're going to be around between now and 3:30 on Tuesday.
Yeah, sure thing.
Okay, or say it, you choose.
I'll write it down. But I generally have I take Friday and Saturday off, but this being the weekend before the first project is due, I'll be around through email. So you can feel free to email me, and I'll hop on Cranium Cafe so we can meet.
Okay, so Braulio is definitely around for office hours, and it sounds like you have office hours on Sunday too, right?
Yeah, Sunday and Monday I'll be around from 3 to 7.
Great, great.
Yeah.
So again, Braulio has a lot more hours for office hours than I have. I have my 1 because I also teach full time. So I teach a lot of classes. So Braulio is great for the office hours, but I have an office hour too, and I'm happy to help you guys out. Other questions? Other questions about the project? Okay, again, you want to have that draft. Okay, I was hoping you had it today, but at least you can send questions, and you can, work with Braulio too. You can work with me in office hours. We're here to help, but if you wait till the last minute, I may not be around at 3:28 just before it's due. That's kind of too late to ask a question on Tuesday because you'll be turning it in. So very important. I'm going to stop the recording.